So welcome back to part 2 of Chapter 6, Project Planning, the Schedule and Budget. Now hopefully you took some time and you reviewed the activity that we are looking at here. We're going to go ahead and expand on this activity a little bit by finding what is called the critical path. And the critical path is the longest estimated time through the project. So as the longest estimated time, okay, this is how we want to manage it. And what we do is we look for, by adding together the possible paths, so A, B to C, right? And notice C is not dependent on on G. So C is going to go to F. If you notice, F only goes to H, so F to H, and then H to J. Notice I goes to J too, and as we get through paths that could go to G and then to I, or G to H, then to J, we will look at that critical path. So what we're doing here is we're creating a table with every possible path through our project. Now realize we're using a very basic project here, okay? So where software is going to help us is as we create what I like to call the pseudo PERT chart in our project software, we would actually create a formalized PERT chart, and it's going to figure out the critical path for us. Because you can imagine on a very complex project, this critical path could be hundreds of different subtasks and tasks that will formulate a critical path. So this is where software is going to help us. But we get this idea. We find that our longest path through the project is A to B, B to D. Now you might say, why is it B to D when I have a 4 here? Okay, it's because we have to continue on the path to find the longest number of work days that the project is going to take. So although this is 4 and 4 leads to 4, 4 leads to 2 here, but we have 5 days in training users. So as we start adding this up, if you notice we go to 3, here we go to 3, which is not in this subsequence the longest days. But notice only G is dependent on H and I takes 3 more days than H. And then of course J, writing the report 1 day. So we find this critical path through the project, and by that we know that we are going to want to manage this. Keeping it on track means, you know, suddenly, okay, this takes 4 days, okay, but notice we need to complete this for 5 days of training users. So we have some what we'll call slack here that we need to look at, okay? And we'll look at slack. So critical path, of course, is the longest path, the shortest time the project can be completed. So it's the longest path, but the shortest amount of time. Now with this, though, there's 0 slack or 0 float, which is the amount of time an activity can be delayed before it delays the project. And we're going to talk about adding in these buffers, if you will, so that if there are areas we don't take the project off track. But the problem with this is we don't want to suddenly add 20% buffer to every single task. That's going to put our project way out there, okay? So at key points, when we do what's called a risk management assessment, if there's high risk for a task, we can add in some buffers. And if we need those buffers, we then have them in our project. We have them in maybe our PERT chart, and we can utilize them. But if that ends up not coming to fruition, that we actually incurred that risk, then we're ready to move on with the project without those buffers. Now, the cool thing is, by not putting these buffers into work days, we're still getting a realistic idea based on what our work breakdown structure is, what our team has suggested time is going to be in order to get the project done, okay? But we've been realistic by adding some realistic buffers based on risk, okay? So project manager can expedite or, crash by adding resources, of course. remember that, as I've stated, adding resources to a project doesn't mean we're going to be able to get it back on track. We can add enough resources to spoil the broth, if you will. You know, too many cooks spoil the broth. So we have to find that optimum number of resources that can keep that project or subtask or package, moving forward, okay, without getting too many people in the way with too many opinions, etc. So as we talk about a PERT, I've given you a basic example of a PERT, and I realize it's a little more difficult to read unless you full screen this video. This was developed in the 1950s on a submarine project, so it's been around for a while. We've sort of incorporated the idea of PERT, Program Evaluation and Review, and Critical Path Method into one conglomerate that helps us. So we've taken these two techniques and employed them together for a statistical distribution of a project. Now, I love PERT charts. Again, if you notice though, if you're new to project management, this is going to look complex. So imagine what this would look like if you presented it to the non-technical entities or resources on your team. So this is where, again, we can take this same data, we can put it into a project management system and literally do one click and say, create a Gantt chart for my customer, for my governance committee, whatever the case may be, making it easy for them to read. But then my team wants to see this technical representation. And what we'll do, right, is that we can put, again, I've seen this done, I've actually done it, where if I have an overall project, I can put a line on where we are today so that we can sort of see this is where we are. And we're going to want to present this data. So a lot of times this overall PERT chart of a project is going to become a poster. It's going to hang on the wall, and people are going to know where we are, what we're working on, okay? The technical folks. Now, the challenge with this, of course, is coming up with those work days. That's the key element. And we need to be realistic on these work days. And one way to do this, the text uses optimistic, most likely, and pessimistic. I've heard, best case scenario, worst case scenario, and then probable case scenario. Okay, so B, best, plus 4 probable, plus 1 W. Okay, so let me explain what's going on. Now, if you'll notice, I am using the same project that we started with, activities A through J. We started by using these most likely estimates. And what we're doing is we're expanding on that, adding a little probability, if you will. So we still have our predecessors. Now, what we've done, either through a poker method or through a Delphi method, is we've gone to experts who are going to do the tasks for us and said, how long is it going to take? Okay. And maybe one expert said, you know what? I can evaluate current technology platform in 1 day. Someone else said, 2 days is realistic. And someone else said, I can see it taking as long as 4 days. So what we did then, if you notice, is we've taken 1. So if we put a 1 in front of optimistic, 1 of the optimistic plus 4 of the most likely plus 1 of the pessimistic. That gives us 6 entries. So that's why we're going to divide by 6 to find the average. So what we've done is we've taken 1 plus 4 times the 2 plus 1 of the 4 divided by 6, and we get an expected duration. So this can give us more of a realistic duration of the work days that it's going to take. So again, we can use those previous modes we've talked about, get our experts, play a little poker to get these. Okay, so depending on how many iterations we do with the poker process, we're going to end up figuring out what the optimistic. So sometimes what we'll do is we'll do this multiple times after sharing some data and actually average the optimistic, average the most likely, average the pessimistic based on a couple rounds of either the Delphi method or inquiry or whatever method you're using. So as we break this down again, using the same paths that we have, because the paths haven't changed, but in this case, the work days have. So as we look through this, we're looking at work days. Remember, our path, I think, was 19, and now our critical path is 20.5 days. So we looked basically at some precedence diagramming in that previous example. So if you notice, finish to start, meaning that, you know, the precedence here is that task A finishes before B starts. Start to start, meaning we can start these together. Finish to finish, meaning we can, once both are finished, we can move forward. And then start to finish, which we don't see much, you know, which is the starting of one precedence on the finish of the other. It's similar to finish to start. And of course, normally with Gantt charts and PERT charts, we're reading from left to right, not doing top to bottom, okay? So, you know, that's how we're used to reading, if you will. So that brings us into that idea of creating some additional time that can be included in our project for risk, okay? And two ways of doing this are lead and lag, or negative lead, okay? So it's starting, lead is starting the next project before the first task is complete. So if you notice, we have some lead time here. What we're saying is that we can start B before task A is complete, even if it's a preceding task, okay, or B is reliant on the completion of A. There's still the fact that we can start B before A is truly finished, okay? So we can create some lead time here. That's going to allow us to reduce the time of the project, if you will, or we can add some lag time. So lag time is the idea that if task A takes longer, okay, we have time for task A. This should actually say task B, by the way. That's really important. So task A can complete. We have some lag time before we start task B. So if you notice, this lag time can benefit task A if it's late, or can benefit task B by starting early, okay? That's where the lead time comes in here. So do we want to do this with every between every task? No, but what we might do is do this on tasks where there is a high probability of risk. Okay, so as we looked at the timeline and people couldn't agree, we can say, you know, there's a high risk. Especially, let me go back previously here, give you an idea, you know, where here is a little bit more risk in that we had 1 to 4, right, with 2. So there's risk here. There's even more risk here, 3 to 5 to 8, right? Whereas here, 2, 4 to 5, there's not as much risk, okay? So we can actually look at these PERT possibilities and say, okay, we ended up with a high variance of time difference, and thus that might indicate a risk where we want to put some lead time or some lag time into the project, okay? There's also the fact to look at things like what's going on in the company, where are we at in the quarter as we're doing this. You know, if we're doing a marketing project and it's the end of the quarter, our marketing team is going to need to be focused on, our sales and marketing team is going to be focused on meeting that quarterly goal, if you will. So we might want to add some lag time for that, so that they have the opportunity to work on what their primary job is, right? So you get the idea, hopefully, by that example. So as we look at critical chain management, I think this is a great place to stop this video and start part 3. So we'll catch you then. Take care.